Hi and welcome to today's session on exponential graphs. So an exponential graph is a type of graph where we'll have a curve which will start off quite steady and then all of a sudden rise and increase quite rapidly. These are called exponential graphs where we are working with a number to the power of x, which is used to actually plot this, finding values of y. X is our variable which we input into this, so these are the numbers that we choose to put into this and find the value of y. X in this case is our power. Some of you may know it as the index, the exponent, or the order. So these can have a positive or a negative power. If it's a positive power, it's going to start off steady from the left hand side, and as it goes towards the right, then it's going to increase dramatically. A negative power is going to start from the right steadily, and as it heads to the left hand side, it itself is going to rise and increase rapidly. We can actually create exponential graphs from using a table of values in much the same way as what we do for linear graphs, quadratic graphs, and cubic graphs. For example, we're going to use the equation y equals 2 to the power of x, where x does not equal 0. So for this, for my table of values, I'm using my x values of -3, -2, -1, 1, 2, and 3. And each one of these will get substituted into my equation for my value of x to find the value of y, which is my subject. So substituting in -3 into this, 2 to the power of -3, that becomes 0.125, or some of you may know that would become the fraction 1/8, and then doing the same for all the rest of the values. Then we plot these as we have here, and we draw a line going through all of our points. Now this is a sketch line, so you're not going to be using a ruler to do this. Draw it freehand and sketch the curve as best as you can. We can also use exponential graphs and the equations to find missing values within our equation. So for our a to the power of x, the equation for this looks like this: y equals ka to the power of x, where k is our constant and a is our number which is being multiplied by the power. So here we've got a graph. Y-axis, our x-axis, this is our curve, and here we've got 2 points highlighted. First point is at 1,8, and the second point is at 328. Now, we're going to approach this in a slightly similar way to what we do for simultaneous equations. Our first equation is going to read like this: 8 equals 8a to the power of 1. Substituting in my value for y and substituting in my value for x. My second equation is going to have my y being substituted in as 128, equaling ka to the power of 3, which is my coordinates of my x value. Now what I'm going to do, I'm going to divide 2 by 1, my equation 2 by my equation 1, and turn it into one big equation. So I've got 128 divided by 8 on the left hand side, and on the right hand side I've got ka to the power of 3 divided by ka to the power of 1. Now what this is actually going to do, it's going to cancel out the k. The k is going to disappear because k divided by k, anything divided by itself, is going to equal 1. 128 divided by 8, that gives me 16. And the a to the power of 3 divided by a to the power of 1, those of you know your indices, you just subtract your powers. So 3 take away 1, that leaves me a to the power of 2. Now, I'm looking for the value of a, so I'm going to square root my left hand side and my right hand side, which is going to leave me with 4 for my value of a. Now, I'm going to substitute this back into one of my equations, substituting 4 into my equation 1. So 4 will be substituted in for a. So I've got 8 equals k, 4 to the power of 1. So anything to the power of 1 is just itself, so this becomes 8 equals k4. And then dividing both sides by 4, we just end up with 1 lot of k on the right hand side, 8 divided by 4 on the left hand side, so k ends up equaling 2. And this was just a method just to find what the value of our constant is by using our coordinates to try and find out what a would be worth. If you like what you see, please subscribe. Thank you very much for watching.